Good morning again.
Morning.
Let's start. How'd you find your practice problems? Different kind of ways. Were all the topics covered? Before you got the practice problem, were all the topics covered? Okay. Like I told you, the last 2 days leading into the final exam is review for application of what you've learned and you've been learning. And so this is a good practice in preparation for your final exam. I'm not going to get it. That's why I went around and checked it already. Okay. You want to put all the notes that you can in here and understand how each problem was solved. Okay. Number one, you are asked to make, okay, I'm going to give more tips again, which probably are repetitive, very repetitive. Okay. You're asked to make, those words are important, to make 150 ml of 3% NaCl. We've done this in the previous packet. Okay. Using, so if this is your to make, this is your from for the word using. These are important words. Okay, because you know where it's coming from. Okay, using a 5% NaCl, the word stock solution. So the question was of each. You analyze the problem. Oh, this tells me that I have to make something from 5 to a 3. From 2. Right? So what type of problem is this? Dilution. So I know that dilution can either be C1V1 equals C2V2. I can use this for dilution. I know. Not talking about the problem specifically, right? But I can also use the alligation or the tic-tac-toe method for dilution. But once I've seen the words of each, I think it is better to use the tic-tac-toe method because it tells me directly how much of each. Yeah. With this, I should only have one missing variable. Are you following? Okay. So in a tic-tac-toe method, you should have 3 concentrations, right? How is that possible? No, it should be this, because there's only 2 concentrations. But in a dilution problem, you have to remember most of the time we add water. And all water should always be zero. So what's my to make? If I were you, I'm going to find the words to make or to prepare right away. And that's where this has to go. Yeah. And then what's my higher? 5%. I'm missing something. A 0 because water is neutral. It is a universal solvent. That's why if we are to put a percentage on water, it's going to be 0. It's a different story when you're talking about pure. Then it's going to be 100 here, then 5 here. Are you following? Okay. So now, or if it says isotonic, that's 0.9%. You remember that? Isotonic is 0.9%. So anything higher than that is hypertonic. So those are hypertonic solutions, okay? Just terminologies. Now I go back to the problem. Tic-tac-toe first, right? 5 minus 3 is 2 parts. 3 minus 0 is 3 parts. Okay. Then I add the 2 together. You can duplicate this to make it 5 parts. I'll bring this down so there's no floating number, and I know this equates to something. Okay? Now I go back to the problem or whatever I scribbled, trying to understand the problem. And I start analyzing where each number goes. Okay? And I start making these boxes. Right? It says 150 ml 3%. I need to find my 3%. And the 3% is right here. So I need to put 150 ml here. Right? I'm just identifying now. And it's saying from NaCl stock solution, I think I have working equations now, right? Because I have this completed. From there is 150 ml. And the question was how much of each. So I can start with anything, right? Say I'll start with this one. Then 3 parts is X ml. All the way? Okay. 150 times 3 divided by 5 is 90 ml. I have to remember that I'm solving the 3 parts. So this goes 90 ml. I can continue doing ratio and proportion to solve this part, or I can simply 150 minus 90 is 60 ml. And this means that you need 90 ml. That's why the box is important. You need 90 ml of the 5% NaCl, and you need how much? 60 ml. 60 ml of the water. Who got this? All right. Bottom line is comprehension. That's why I'm giving you these tips. To prepare, to make, from stock solution is your original bottle. You got this one again, hands up? It can't be 90 ml of water and 60 ml of 5% NaCl. You're wrong. It's a different concentration if you do that. And this is why the box helps all the time. Are you following? Because it tells you it's the 5% that's 90 ml. It's 60 ml for the water. That's why I put the boxes. And you need to make, which was part of the given, 150 ml. Have to work for you, but you have to understand the problem first. Let me see hands again. Let me see. Okay, almost everyone. Next one, number 2. Give me answers. 100 ml I heard of each, correct. 100 ml of each. 100 ml of D5W and 100 ml of D10W. I don't think I need to explain that. Number 3, a 20-gram vial must have 90 ml of diluent added. It has a powder volume of 10 ml. How many milligrams are in each milliliter of the reconstituted solution? Answer. Correct. 200 milligrams per milliliters. You have to understand that 90, this is a common question on the PTCE. 90 is only the diluent part. And it told you that that powder, when dissolved, contributes what? How much? 10 ml. So your denominator should be 100, not 90. Remember, to make a solution, you have a solute. A solvent is also your diluent to make a solution. And in percentage and strength of the drug, the denominator should always be total. Who didn't get 200 milligrams? Be honest. Did not. Did not. Okay. Did not. Okay. What are your answers? 220. Why? What denominator did you use? 90. But you understand now? You cannot use 90 as a denominator because strength, remember, grams over grams, volume over volume, or ml over ml, and grams over ml, the denominator will always be total amount of solution, not just the water part. Is that clear now? A lot of questions like this get thrown in the PTCE. Whatever answer you get will be in grams. Then you convert that to milligrams. Did you ask me about this?
No, not this one.
I did.
You did? Yeah. But your question was similar during the tutoring. Yeah. We were. Okay. Number 4. What's the answer to number 4?
I got 4.
5.
There's many different ways to solve this. Many different ways to solve it. I haven't heard the correct answer.
13 grams per night.
Closer. The correct answer is 200 milligrams per ml.
Why would you put it in milligrams if the other concentration was given in grams?
You could do 0.2 grams per ml. It depends. Like, it didn't say specifically, so you could. Okay, so you could. It can be 0.2 grams per ml if the given is 1 gram per 10 ml. But usually labels will tell you 200 milligrams per ml in real life. Okay. Okay, I want you to try, after me giving you the correct answer, 200 milligrams per ml, I want you to try to work it backwards before I show the work. Number 4. We're on number 4. Why do you think it's 200 milligrams per ml? Like I said, there's a couple of ways to solve this. You can do the percentage, and this tells you that concentration or strength of the drug can be calculated in ratio, can be calculated in fraction, can be calculated in percentage. And you can flip-flop these things for you to understand the problem. That's why I said there are multiple ways to solve this problem specifically. You can convert them to percentages if you want to. Grams per ml. Try working backwards before I show you the work. Anybody who got that one? You got it, Michelle. But you set it as 0.2 grams per ml. Once it becomes less than 1, we convert them. I mean, the labels are converted to milligrams strength. Because they're not going to put 0.2 mg. Instead, they're going to put 0.2 g per ml. They're going to put 200 milligrams per ml. I just gave the answer. Work backwards.
No.
What was that? Possible ways to solve this. Yes. Yes. Okay. Michelle, anybody else who got 200 milligram per ml out on top of Michelle? Okay, Michelle, can you show your work on the board, please?
Anyways,
Yeah. There are multiple ways to do this. Huh? So concentration can be in fractions, can be in ratio, can be in percent. See? Percent as well. We need to understand it better. But by the way, we have to do MLs and stuff on the every step. ML, if you convert this to percent.
10%.
Correct. That's 1 divided by 10 times 100. That's a 10%. So you can work using percentage if that clicks. You can understand that better. The first part that Michelle wrote on the board, what does this tell you? How much did the powder dissolve into? What's a powder volume?
Well, something in it.
Black, right here. I got 3 in black.
Valve into a fingernails on the first part.
Yeah, she calculated based on the strength first, 1 gram over 10 ml. That's the concentration given to you, right? But you are to reconstitute a 10 gram. So how much is the total volume for that one? After calculation, 10 gram over 100 ml, that's the proportion, right? But how much water was added on the first part? 95, which means vancomycin, the active ingredient, dissolve. What's the powder volume of vanco? 5 ml. Because the total solution became 100. The total solution became 100. You added 95 water. So how much did the active ingredient dissolve to? And that is important to figure out. The 5 ml. Because in the next equation, you already know that that vanco will dissolve into 5 ml solution. So your denominator in the next problem should not be 50. Your denominator should what be? What should it be? The next equation was you have to add 45 ml. Is it still going to be 45 for your denominator? No, because that's just the water part. How many times did I say the denominator will always be total? Total. The combination of the active drug and the water to make the solution. So your answer should either be calculation-wise 0.2 grams per ml, or if you're asking in milligrams, 200 milligrams per ml. Did you see? This is a common problem in the PTCE because it wants you to know that you know concentrations very well. Most people will just use solvent or diluent. When I started the percentage topic, did I put solvent at the bottom? Did I put solvent at the bottom? No. How many times did I write total solution? Many, many times. Because it's a common problem in the board exam. Students only use the solvent or the water part or the diluent part. You have to remember. You have the solute, which is your active ingredients. You have your solvent, remember me showing this many times? Okay, which is also called diluent, usually water. And what happens to the powder when you add water? It becomes a solution. And this is your denominator, the combination for you to get the concentration. So if you use 95 only or 45 only, that's wrong. You start off with, if 1 gram is 10 ml, 10 grams is what? Proportion. It's like quantity to be dispensed. Quantity to be dispensed, the quiz that you just did. That's how you start. If 1 gram is 10 ml, 10 grams is what? Isn't that quantity to be dispensed? 100 ml. Okay? But then there's a second statement or second problem, which is, what if we add 45 ml water? Still the same, a 10 gram vial. What will that strength be? That's a grams over ml problem. So 10 grams over, what is now the strength? I cannot use 45. I should not use 45 because it has to be the total solution. From the first problem, you figured that the active ingredient vancomycin dissolves into 5 ml, which means your denominator should be 50, not 45, for you to get the concentration. Do you understand? You still don't understand? Hello? No, no. Yes, no. You still don't understand?
Not really.
Ms. Shaw, can you speak in another language, please? And explain?
Okay. So really you're solving two different problems. The first problem is you need to find out your powder volume. So that's what I did with my powder. I knew that I had 10 grams of solvent to begin with, so I needed the concentration to reflect that. That's why I changed 1 gram over 10 milliliters into the 10 grams over 100 milliliters. So I know 100 milliliters is the volume of the total solution. So that includes the powder volume, and that includes the water that we mixed in with it. The problem tells me that I had 95 milliliters of water. So if I subtract 95 from 100, that gives me the powder volume, which is 5 milliliters. Now that I know the powder volume, the second part of the question is asking what happens if you mix that with 45 milliliters of water. So you take your 10 grams of powder and you have your 45 milliliters of water plus the 5 milliliters of powder, and that gives you a new concentration of 0.2 grams over 1 milliliter.
Any other one who wants to speak in a different language too? Because it's a combination of 3 different topics. I think that's what's confusing you or messing you up. In pharmacy, you have to apply. Sometimes the problem is like that. You have to apply 3 different topics. The first part of her solution is to solve what the final volume is, or in other words, quantity to be dispensed. Comes in 1 gram per 10 ml. But are you dissolving 1 gram? So you have to find how much that total solution is. Because a concentration is always the nth time, weight over weight, volume over volume, or in this case, weight over volume. And if it's weight over volume, the unit will always be grams over ml, correct? And what is the denominator for all those? Is it just the water part? Total what? Total amount of solution or total volume. So your denominator can't just be 95 here, or can't just be 45 here. That's why she tried to solve how much is the powder volume for me to get the correct concentration. I know from the first equation I did, okay, trying to use the proportion, because 1 gram per 10 ml is a strength or a concentration. If you use ratio and proportion, this means that 10 gram for every 1 ml is the same as 1 gram per 10 ml. She found out the total volume of the mixture, combining the powder, active ingredient, and water. So if she is to solve the next part of the problem, she already knows that that active ingredient, vancomycin, no matter what, based on this concentration, will dissolve into a 5 ml equivalent. Okay? Knowing that your vial, second part of the problem, that your vial, no matter what, will be 10 grams. Correct? But there's another condition. You have to add 45 ml of water. If you do 10 grams over 45 ml times 100 for percent strength, or 10 grams over 45 ml, you will get the wrong answer. Going back to what's the formula for concentration for grams over ml? Weight of solute over What kind of volume? Total volume of solution, not just a solvent, not just a diluent. So her first part is important to figure out how much that dissolves into. So her final volume that she needs to use is 10 grams over 50 ml because that's concentration, not just a water part. And so she solved it. She may end here for purposes of calculation, 0.2 grams per ml. Okay. It's a multiple choice question, which your final exam will be. Okay. And it's all in milligrams. Then you have to convert this to milligrams per ml. In reality, you won't see concentration like this. Once it's less than 1, you go to the next metric unit. Okay, that's why this strength is 200 milligram per ml. Calculation purposes, this is your strength. How much is this in percent? 0.2 grams over ml times 100 if you want the percent, which means 20%. But this has to be in grams if we're talking percent. Remember, it all boils down to the initial lecture or topic about concentration. It won't divert from that. It won't. It will never divert from that. Okay? So you have to know what concentration comes in. Weight over weight, volume over volume, over weight over volume. The most common, weight over volume. And you have to know that when we're talking about concentration weights, it will always be in grams, even if the unit is invisible. If we're talking volume, it will always be in ml, even if the unit is invisible. Okay? Final exam, the board exam will throw you questions on concentration. And like I said, a lot of test takers think that they're taking an allegation question. I mean, they're answering an allegation question, but it's not. It's a lot of this percentage question, concentration question, not really allegation. The first one I did is an allegation question because you're mixing substances. Okay. When you're adding water, it's dilution. When it's alligation, usually you're mixing two concentrations to make the middle concentration. Is that clear? Okay. Anybody else who wants to use their own language to explain it? I tried. Michelle tried. Anybody else wants to try? Who understood? Who still don't? Okay. If you still don't, maybe you should watch the initial video about concentration because I'm repetitive enough. I said it many times. The denominator will be the total. Total amount of ointment, if it's grams over grams, right? Total amount of the solution, which means the combination. Okay. Moving on, the pharmacy has received a prescription of 30 grams of a triamcinolone, 2% ointment. How many grams of triamcinolone will you need to prepare this prescription? Answer?
6 grams.
How could you answer that? That means you know concentration. Okay. So remember, this is an ointment. So if I'm to talk about concentration or strength of this drug, what is that? Weight over weight, volume over volume, or weight over volume?
Weight over.
That's weight over weight. You saw the word, right? And weight over weight pertains to grams over grams. This is when you pay attention, those who still don't understand. Okay? When you say grams over grams, this is grams of solute over total grams of the solution. But when it's semi-solid, we don't call it solution, we call it a compound. In this case, ointment. Right? If I want to make this strength or concentration a percent, what do I do with this problem? If I want to make it a percent, what do I do with the givens? Thank you. You multiply this by 100. If I want to use ratio and proportion, because there's a strength given, or a denominator given, then my denominator should be 100. Then I don't have to multiply by 100. That's why I said it's on the percentage topic, the strength topic, the concentration topic. In this case, if I'm to put this in terms of this equation, it's telling me that the total ointment is 2% strength, right? The pharmacy has received a prescription of 30 grams of triamcinolone ointment, which means where does the 30 grams go if I'm going to stick with this one? The bottom, because it's the total ointment. You following? Ointment is abbreviated like this, but you may see ointment as UNG. Take note, this shows up on the board exam. It came from the Latin word unguentum, UNG, ointment. Okay, but now we put OINT. So that means this is your XG, and what is it looking for? The active ingredient, right, of the solute. This is what that equation means. But I've seen that the problem says off. Really? It can be convert your 2% into a 0.02. What's off? The number should talk to you. The word off means times. What's equals? Yes. The problem was simple, okay? But it actually rooted from this. Just so you know. That's why I said the foundation of concentration and strength is this topic. Is that clear? Who got 0.6 grams? Everybody. Okay. Number 6. A 6-gram vial must have 10 ml of diluent. Here you go again. Something similar. If I were you, I'm going to underline diluent. That means it's just the water part added to it. It has a powder volume of 2 ml. How much will be in each milliliter of the final solution? Most of the time, what people will do is 6 grams because they're excited over 10 ml. Is this correct? No. How come you know that it's no? How come you have a hard time understanding this when you could perfectly understand number 6, which is very similar? It's similar. It's just a combination of 3 problems, 3 equations. Quantity to dispense, okay, concentration, powder volume. Okay? So what should be, if this is wrong, what should my equation be?
6 grams over 12.
6 grams over 12 ml. Look at this part. Because you saw the word powder volume. Did you see? Never just use water. That's why I highlighted many times the denominator is not just water. It's the total amount of ointment in grams over grams, total volume of solution in volume over volume, which means a combination of the solute and the diluent. And in weight over volume, it's the total volume of solution. Okay? And what is the answer here? The question was, what is the final volume of the solution in milligrams? Because your answer here will be in grams per ml. So you have to convert that. So what's the answer?
600.
Okay. Because you will end up with 0.5 grams per ml here, correct? Right? But the question was specific. How much is that in milligrams per ml? So this becomes 500 mg per ml. If the question was, what is the strength of this solution in percents? What do you do?
50.
What do you do with this if the question was percent of the solution? Times 100. Goes back and forth, back and forth, back and forth. 6 grams, because it's the correct unit already, grams, over 12 ml. It's the total. You didn't just use the 10. You combined it with how much that drug dissolved into. So it's in the correct format. You just multiply it by 100 if the question was, what is the strength of this drug induced? Are you following? We're back and forth, back and forth, back and forth with the same topic. Concentration can be converted into ratio. Concentration can be in the form of fraction. And ratio is also a fraction, right? Concentration can be in the form of percent, and percent can be a decimal. How do you get percent? You multiply it by 100. Just back and forth, just back and forth. It's the foundation, the beginning topic, okay? Who got 500 milligrams per ml? Right. If you didn't get this answer, my guess is your denominator is 10 ml. Carla's like, yeah, that was my mistake. Now you know, okay? Now you know why Michelle did this. Because in her initial solution, she figured she used 95 ml, but the final should be 100. That tells me that vancomycin dissolved into a 5 ml part of the solution, which means 100 ml vancomycin has 95 ml water and 5 ml vanco, the active drug. Yeah. And in this case, okay, a total 12 ml solution has 10 ml water and 2 ml of, did they say the drug? It just says drug. It came from 6 grams technically. That clear? Yes? Okay. Go on. An oral medication requires reconstitution. What's reconstitution? Let's define reconstitution first. What's reconstitution? Those of you who've been here a while, you know what that is. Think about the yellow powder. Think about oral suspensions. Adding water to make it either a suspension or a solution. Okay? And that adding water changes the strength of the drug. You're diluting the drug. Okay? So an oral medication requires reconstitution. Oral. So we're talking about pediatric antibiotics here, like amoxicillin for kids. They come in powder form. The rule is do not reconstitute until the caregiver, the parent, is right in front of you. Because if you receive a prescription for an antibiotic and you reconstituted that antibiotic that came in powder form, okay, and the parents don't believe in antibiotic, you're left with an inventory that you need to throw away. So the rule in compounding is you don't add that water and you don't reconstitute until the mom, the dad, or whoever the caregiver is of the child is right in front of you because it's so fast to add water. Right? We don't know if they're going to pick it up or not. So wait until they get here. They get to the pharmacy. Going back, the concentration of the reconstituted medication is 300 mg per TSP. The dried powder is 2.5 grams with a volume of 9.6 ml. How much water do you add? This one is in reverse. But you got to go back to, there's a drug part, there's a water part to make the solution. This one you're going to have to extract the water part. Okay, any answers?
32.07.
32.1 ml. Anybody who got that? Michelle, one more time, please. Alex, you didn't get this one?
No,
Finals is on Wednesday.
I know.
Online class, the recording of this topic that we did the last 5 days is 3 minutes. In an online class. You have to understand it in 3 minutes. 3-minute video. We're doing this for 4 or 5 days already, okay? Face to face, different voices, okay? Let's change this. Original lesson plan, allegation is only 1 hour, so I fought so hard to buy you time. Okay. And I don't know how they're doing it in other campuses, if it's just an hour or a 3-minute explanation of this. No. And their campuses require PTCE. The pass rate is really low. Okay. We're in Nevada, PTCE is not required, but we got 100%, 90 something time on this. You try to buy time. Okay. Almost the entire class still doesn't understand the topic. I expect almost the entire class to come to tutoring. 2 hours today. Tomorrow, 55 minutes. Because I need to be in Currituck tomorrow. Oh, you did it, dimensional analysis. Yeah. That's whatever. You want to do ratio and proportion, or I will do ratio and proportion on this part. Okay. See, Michelle and I are tandeming right now. Believe I remove, okay. Do it in different ways. Michelle did dimensional analysis on the first one. If you don't understand dimensional analysis, just look on my side. Okay, that's the first part. Do you understand where the 5 ml came from? Where did it come from? Do you understand why I set it up this way? Because a concentration should always be in. If you want it in percent, should always be in what unit? Grams over ml. So you can skip this part because I know every one of you don't like dimensional analysis. The first part of Michelle's problem is this. Okay. Here. You want me to explain what I did? Yeah. Go here. Right there.
Okay. So the problem tells us that the concentration of the reconstituted medication is 300 milligrams per teaspoon. So we converted this to 6% concentration. So that is our goal, is to 6%. So that goes in the little middle of our tic-tac-toe board. We know the weight of the dry powder is 2.5 grams and the volume is 9.6 milliliters. So we can figure out the concentration of our solute is 26%. So that goes up top And water is of course 0%, and then I used allocation to find how much water we need.
Because the question was how much water, correct? Which means you can also use C1V1 equals C2V2 in this problem, because we already calculated it in terms of percent. And I think the way to solve this problem is to start off with percent. And again, I go back to any strength can be converted to fraction, can be converted to ratio, can be converted to percent. Okay. In this case, Michelle used tic-tac-toe, and that's fine. 26%, like she said, the problem said to make this concentration. For me to understand it better, I'm with Michelle. I have to make it a percent. And that's why I solved it this way. Okay? But it's asking you how much of the water. Again, you guys know this. 26 minus 6 is? 6 minus 0 is? But you got to go back to the problem again. This is when I pause and read the problem. Which one is 20? Which one is 6 parts? I can bring this down 6%. Okay? And this is 26 parts. Now I got to go back. This is when I pause and read the problem again because I'm missing a variable that I need to input. Okay? 2 grams with a volume of 9.6 ml. So this is the 26%, correct? That's what the problem says. So where's my 26%? So I put the, how much? 9.6 ml. Well, I have a working variable now, no matter what, right? Okay. So 6 parts is 9.6 ml. What are we solving? Water part, correct? 20 parts. Let's do. What is that? 32.07, which is 32.1 ml. So after I solve this, any problem can show up now. So what's the total? .6 ml plus 32.1 ml can be 300 ml.
41.7.
47 point?
41.7.
41.7. Okay. But the question was only how much? So your answer should be this. I'm just presenting to you possible questions. Let's try C1V1 equals C2V2. Yeah, let's try that one. Because I can see I have this, but you know, if it's water part, it's hard to do the C1V1 equals C2V2. Remember? If it's the water part you're looking for, we tried that the other time, like, oh, there's going to be 2 variables now. Alligation. So try C1V1 equals C2V2. What's the initial concentration? 26%. Okay. Do you know the initial volume? No, you don't. What's the final concentration? 6%. Do you know the final volume? No. Right here, if the problem stated 41.7, then you can use this, but you don't know the final volume. And that's why the best way is still this.
The initial volume is 9.6.
You got an initial volume?
Yeah.
Oh, there you go. Perfect. Thank you. 1 Oh, no. In the problem, it's not given.
You can use 9.
You solve it first. But what I'm saying is, if you're just looking at,
It is given in the problem.
it is given in the problem?
Yeah, it says the dry powder is 2.5 grams, the volume of that.
Oh, yeah, okay, perfect. C1V1 equals C2V2, which means we can solve it. Thank you. What's your C1 concentration? It's 26%. What's your initial volume? 9.6 ml. Thank you. And then what's your C2? Final volume will be 6%. Then you can calculate the final volume. And this will be 41.7 ml. The problem is this is the total. And how do you solve to get the water only? 41.7 minus 9.6 ml, which is the first concentration amount, 26%. And that's how you get water using C1V1 equals C2V2. I totally missed this in the problem, okay? And that will still give you 32.1 ml of water. Came out the same. 2 ways, okay? Again, it just shows you that you can use the tic-tac-toe method for dilution, whatever clicks in your head. Okay. If this wasn't given, then like I was starting to do, like you can't, okay? But there was a given volume. So I could do C1V1 equals C2V2. Understand this? Number 8. This one specifically said use the alligation method, meaning the tic-tac-toe. You need to prepare 60 grams of 3% cream from a 1% cream and a 10% cream, which means what are your two percentages that you need to mix? 1 and 10 to prepare 3%. Okay. Answer, how many grams of cream?
10.3 so 10%.
Very good. How many grams of the 1%? It's 47. Who got 13 grams of 10% cream and 47 grams of 1% cream? Six point something. Yeah. Yeah. 46 point something. Like, because when you combine that, it becomes 47. Okay. 46 point something. Okay. Or 47. Yeah. 13 grams of 10% cream and 46 point something of 1% cream or 47 grams of 1% cream. Who got that? Hands up. Oh, so everybody, which means you know how to set up tic-tac-toe. You know how to use alligation. Okay. Moving on then. How many milligrams of the drug are in a 30 grams of 15% cream? 4,500 mg. Again, it can be as simple as convert your grams to milligrams times 0.15. Did you see that? Because it's off 30 grams of a 15% cream. The first thing I'm going to do is to convert my grams to milligrams because the problem said how much is that in milligrams. And then I convert my percent to decimal. 30 grams of 15% cream. Or if you started off with 30 times 0.15, you will get 4.5 G. Convert that to milligrams, 4,500 milligrams. Who got that one? Hands up. Okay. Next one. That was a percentage and conversion problem. This one, you've been doing this all the time. Let's see. There are 40 grams of dextrose in a 500 ml solution. What's the percentage?
8%.
Can be as simple as grams over ml times 100. Okay, moving on. How many milliliters of pure isopropyl alcohol are contained in 750 ml of isopropyl alcohol 91% solution. What's the process here? Emily said C1 V1 equals C2 V2. That will work. What else? Alligation. You can use alligation too. But if I were you, I mean, if I'm to take this test, I see that there's two strengths and there's one volume. I don't see two strengths, but I know there's two strengths. Why? What's the other strength that's invisible here?
Pure.
The pure. What's my C1 then? 100%. What's my V1? Do I have a V1? No, that's your X. What's my C2? 91%. And what's my V2? Because it's to make the 750 ml. So what's my answer? How much of the pure do I need? 682.5 ml. So if I'm going to do a follow-up question, how much is the water that I added here? Correct.
67.
This is 750, which is your total. And the initial volume is 682.5 ml, which means I added how much again, Alex?
67.
67.5 ml. Did you see that? There's always the water part, and there's always the active ingredient part or the drug part. Was that clear? Yes? You see how I'm trying to, okay, follow-up question, because the PTCE may ask you this, or the final exam may ask you this. Okay. Number 12, you can just disregard millimole and think of whatever strength that is. It doesn't have to be millimole, okay, for purposes of calculation. Yes.
Sorry, just a double check. I think answer for number 11.
11 answer, everyone who got it.
62.
And that pertains to what? Is it the water or the pure alcohol? It pertains to the 100% alcohol. Okay. But we just did verbally the C1 V1 equals C2 V2. Can you do tic-tac-toe on that one? Yes. What's on top? 100. What's at the bottom? 0. What's at the middle? 91. You still could do that. And then go back to the problem. Am I being asked the water part or am I being asked the pure part? Yeah. And then find your box. You must add 9 millimoles of an inorganic phosphate to an IV solution. You have 15 millimoles per 5 ml available. How many milliliters should you add?
I got 3.
3 ml. Everybody got that? You know how to solve it? Right? You do ratio and proportion. It is quantity to be dispensed problem. Remember? Quantity to be dispensed in liquid form problem. Okay, next one. A patient receives an IV solution containing 500 ml of a 10% IV fat emulsion. How many grams of fat did the patient receive? 50 grams. That is percent grams over ml. What's missing? The grams, the solute part. Or it can be as simple as 0.1 times 500. Because there's a word off. 50 grams. 50 grams is the answer. And moving on, number 14. You need to prepare 2 liters of 5%. It's said in there, weight over volume. Okay. In reality, you don't see this in parentheses. How much of a 75% stock solution should you use? 2 possible ways. First one, C1V1 equals C2V2. If we're using C1V1 equals C2V2, what's my C1? 5 to go from higher to lower. Good job. Do I have a volume? No, I don't have the initial volume because that's the question. How much of the 75% do I need? Correct? Equals 5% times, what do I put in the next parenthesis? 2000 ml, because I know that volume should be in ml, especially in concentration. And what's the X going to be? Correct, 133.33 ml using C1V1 equals C2V2. Can I use tic-tac-toe? Yes. Okay. What's my higher strength? 75 on top. What's my lower strength? 0. What's at the middle? 5%. Then you solve. The question here, though, is what is 75%? Right? So you have to look on the top box after you do your Asian proportion. Who got 133.33 ml? Ointment. What strength is that? What concentration is ointment? Grams over grams because it's weight over weight. Remember I told you semi-solids. Use the alligation method. It told you what to use to solve this problem. 45 grams of zinc oxide, 10% ointment. Using a zinc oxide 5% ointment, a zinc oxide 20% ointment. How many grams of each ointment will you need? I want answers. 20% ointment would be 15 point something or 15 grams. Okay. 5% ointment will be 30 grams. Who got those? Good job. It's telling me that you know tic-tac-toe. And it's telling me at the beginning, you didn't comprehend the problem. Because it's 3 parts. Okay. It's a combination of 3 topics. Okay. Next one, number 16. How many grams? You've mastered this. We did worksheets on this one. How many grams of dextrose are in the 750 ml of D10W?
75
Correct. 75 grams is the answer. Pay attention to this number 16. Did you see that 750 ml didn't say in a 750 ml water? It says the entire solution. So that tells you if you're talking about strength, it's total. Okay. Answer to number 16 is 75 grams. Number 17. We did this as well in the other worksheet, right? You're asked to add 44 milliequivalents of NaCl to an IV bag. NaCl is available as a 4 milliequivalent per ml solution. How many milliliters would you add to the bag?
11.
What process did you use? QS stands for quantity sufficient in Latin. In English, quantity sufficient. You got to spell it right. Sufficient. S-U-I-C-E-N-T. Good job. Number 19. What problem is this?
Single dose.
Single dose quantity to dispense. Right there. Give blank ml per dose. Right? Answer is 1 ml per dose. Correct. Last one. What did we not talk about? That is the answer.
Number 19.
1. Any questions? Okay. Here's what I'm going to do.